sideways.
3x
minus 5.
You're gonna start with that?
X is less than 3.
So no one be able to use the 3 conditions. Now we know that the 3 conditions, right?
What are the 3 conditions? For a limit or for continuity?
9.1.
Oh,
Very
right.
similar.
Limit.
Right. They are very similar.
Hi,
Right.
come on in.
Yeah, got me room.
Yeah, absolutely. Ba-dum-ba-dum-ba-dum.
Move my
Appreciate
bag
it.
over, then you can just.
And then you can
sit here
park
if you
on this
want.
since I think Nick is working off his lap, so there's a little spot for you.
Yeah.
Sorry, guys. Yeah. Like, don't worry about like kicking the pillows off, just shove them to the side. That's what they're there for.
General
And-
limit.
Yeah, general limit, we're gonna talk about that.
Okay. Is that what you're doing right now?
Mm-hmm.
Okay.
So the 3 rules for a limit is that the limit
3 squared, or 3 is 9 minus 5 is 4. 2x is 6 minus 2 is 4. X is greater than 3. Okay. So the place where people struggle with this stuff the most is the piecewise defined functions. Okay. So with piecewise defined functions, if I give you one of these and I ask you to find the limit and find the function and check for continuity, that's the kind of stuff that you should be looking for. Okay?
What stuff should you be looking for?
This kind of problem. This is the
Oh,
kind of
okay.
problem I might give you.
Okay.
So if I ask you to find limits, find continuity, this is what we're gonna do.
Okay. Yeah.
So remember with limits, it's about making cars crash. So for you, Autumn, I'm just gonna scoot this over. If we can put a car on the road to the left and a car on the road to the right and make them crash over that X value, the
That's a
limit
limit.
exists. Exactly. So what that looks like mathematically with these piecewise defined functions is we're gonna stick a car on this one, because that's the road to the left, that's X less than 3. And we're gonna stick a car on this one, that's the road to the right of 3. And we're gonna try to crash them over 3. Which you might be able to do. So if we shove 3 into this top function, what do we get out?
3 times 3 is 9, minus 5 is 4.
4, right? If we shove 3 into this bottom function, what do we get out?
6 minus 2, 4.
4 equals 4, so those cars are gonna crash. So on this.
Too fast.
Okay. So what we just did, you guys, is the limit as x approaches 3 negatively equals 3 times 3 minus 5 equals 4. So my upside down writing is crap, Autumn, but you'll get used to it.
Why is it
Okay.
negative? What do you mean
It's not
by
negative, it's 3 negatively.
Yeah, what do
So-
you mean by that?
So we're approaching 3 from the left-hand side.
Oh, okay, that's
So
what.
you remember
okay.
convention? Here's negative
Yeah.
x, here's positive x. This is your left hand, this is your right hand. So when I say limit as x approaches 3 negatively, I mean I'm coming at it from the left-hand side,
Okay.
the negative side. So it's literally the left-hand car. And what was the limit as x approached 3 from the right-hand side, or x approaches 3 positively?
It's also 4.
Yes, that was 2 times 3 minus 2 equals 4. Well, remember the 3 conditions for a limit. The left-hand side has to exist, the right-hand side has to exist, and they have to equal each other. So if 4 equals 4, we're good to go. So the general limit here, as x approaches 3, is going to be 4. So far, so groovy, guys?
Mm-hmm.
Okay. So when we're doing limits, we have to test both sides.
So if we were only given like not 2 equations, like so you're just given like one
A
equation.
single equation, so
yeah.
not a piecewise different
Yeah.
function, just a regular function?
Right. Will we be given an x value to be plugged in?
Possibly. So I'll give you an example of what that might look like as well. Okay. So if I asked you to check for continuity here, we're only partway done because we have the limit is 4. Now we have to check the function. What's the function at 3 here? Ooh, I love this song. Turn this up.
So to check continuity, you're plugging 4 into the function.
Well, we'd be plugging 3 in, right? Because the place where all this is happening is at x equals 3. So where can I plug 3 in?
Either or, right? Or as
Neither,
an
Autumn. Yes. Why neither?
because there's no line underneath.
Yeah, this is x less than 3. This is x greater than 3. At no point did I say, could you plug in 3? So this is D and E. So even though the limit exists on this function, there's no function at 3. Therefore, this is discontinuous. Does that make sense?
Yeah, and the function is the solid line on the graph, right?
The function is
I mean the solid dot.
anything solid.
Yeah.
Yeah, anything solid.
Like posts, right? You said
if
open doors.
Yeah, if you go to the beast back here, any road is a solid thing. Any post is a solid thing. Potholes are like open doors.
One of her first days, she did say there would be something like missing the
Yeah. So the beast is definitely going to be on the test. I'm
Like
going
this
to
is actually not.
tell you guys that.
It's
Yeah.
just like a two-part thing.
It's a two-part thing. So if I had put a little line under here or a little line under here, then this would be different, wouldn't it?
Mm.
It would all of a sudden become continuous because I would have a place I could plug in 3 and the answer would be 4.
So
For continuity, the rules are the limit has to exist, the function has to exist, hey Zach, and they have to equal each other, right? Okay.
Oh, is that what the equal, like when you say it has to equal to each other, that's when you mean that the greater than
limit.
or less than have to have that underneath dash?
Yeah, so you have to be able to, first you have to be able to plug the x value in, right? What if I asked you to check continuity at x equals 5 on this function? Could you do it?
Yeah,
well,
right? Because
5.
5 is greater than, or 5 is
Right.
greater than 3.
So we would literally be using this for the whole thing, wouldn't we?
Yeah.
Because if we want to put a car a little bit to the left of 5, that would still be greater than 3. If we want to put a little car to the right of 5, that would still be greater than 3. So we would just be using this guy the whole time. Well, the limit would be, what's 5 times 10 minus 2, or 2 times 5 minus 2
7.
would be 8.
Oh, yeah. 8,
So the
sorry.
limit would be 8, and so would the function, because you could plug a 5 into this.
But the limit wouldn't match the top if it was 5. Because it would be 10, 10 and 8.
Not necessary.
Oh.
Because we're working everything to the right of 3.
Okay.
Does that make sense?
Okay.
So
this
if
is-
we're on 3, we have to test both. If we're to the left of 3, we just use this guy. If we're to the right of 3, we use this guy. But if we're on 3, we have to test both. Because immediately to the left of 3 is this rule, and immediately to the right of 3 is this rule. So these rules matter. They absolutely matter.
So if you were gonna say, find the limit if it exists at 2, so we would use the top one because
And
2
only the
is
top
less
one.
than 3.
Exactly.
And then if obviously with the 5 you said if it's 5 it's greater than 3, so
Right.
you use the bottom one.
And if we test
Okay.
at 3, we test both of them.
But you can't do that right now because there's no equals.
Exactly.
Okay.
So
Got it.
there's that. Now Autumn asked about something else. What if I give you a function like this? X minus 2 over x squared minus 4. And I ask you guys to check this for continuity. What would you do?
Squared minus 4
Factor it out.
minus 2. Bring the bottom up.
What did I do?
Bring the bottom up? Nah,
Bring the bottom down.
it's already down.
Oh.
What do you think?
Oh. So you can set. So if x is 2, then you're gonna have a vertical asymptote, possibly. It's
Possibly.
the A,
Either
something
a
over
vertical
0.
asymptote or a hole. So remember, you guys, damn it, I wanted that song, but it's too damn loud. So remember, you guys, when I'm asking you for continuity, what I'm not asking you to do is look for continuity for all x. I'm trying to break continuity. I want to break it. Okay, that's my goal. So how do I break this function? If there's a way I can break it,
Set it to 0.
set what to 0?
X. So 2 minus 2.
The bottom, exactly. This going to 0 tells me whether it's a hole or an asymptote. This going to 0 tells me whether there's any kind of discontinuity in the function. Remember, holes and asymptotes share the trait of the denominator being 0.
Oh, okay.
Okay? So if we set this equal to 0, we get x equals 2. So this is discontinuous at x equals 2. And we're done.
Or are those the ones that you said, like, is there anything I can do to this to make it go to 0? It's like, yeah, you could put a positive 2.
Yes.
It's like,
But-
and that's all you need to do.
Exactly. That's it.
What? Oh, okay. Because
Yeah.
they're both gonna give you the answer to discontinuous. Oh, okay.
Would, like, on the test, will it just say, like, check for continuity, or will it be more like,
Tell me what kind of discontinuity there is if there's one present.
right?
Well, in that case, plug the 2 into the numerator. And what do you get out?
0.
So you get 0 over 0, which tells you it's a what?
Whole.
It's a whole. And there's your answer. So have you guys been way overthinking these?
Yes.
Yeah.
Well,
The vertical asymptote is where there's a 0 at the bottom, right?
0 at the bottom and a non-zero at the top.
Non-zero at the top. Both zeros, it's a whole. Okay.
Yep. A for asymptote, O for whole.
0 over
A
0.
for any number other than 0.
0 over 0 is a whole.
Mm-hmm.
And then A over 0, which means any number,
Yeah.
is a vertical
I guess
asymptote.
that's a good way to remember it. 0 is a whole.
Yeah, O for whole. O for whole. If it's a non-O, it's an asymptote.
Can you do another one?
And now we go to Minnesota.
When do you have to factor? I thought it was like 0 over 0 or something.
When you're taking the limit. So if you're taking the limit as x approaches some number,
And then you get it, and then you
You
get zeros. That means
only
you have to
factor if you get a 0 over 0 answer.
I didn't even understand what C and B
C is just some number.
Just a number.
C is just some number. So we could do the limit of a function as x approaches 2. So we would plug 2 into the function.
Yeah.
And you'd either get some answer out, in which case you're done. You'd get some answer over 0, in which case it's a vertical asymptote and it's D and E. Or you get 0 over 0, in which case you factor cancel and retake the limit. And you have a hole at that x value. So that's all that means. Okay?
Can you talk about like when you were doing the beast and then there's like the different, so you were like, okay, here's a hole and it's a pothole, and then here's a pothole that's actually filled within the road. Like, how do you know what the limit or the vertical asymptote or whatever it is?
You can just use it. You can write it.
So I'll just take this beast right here. So let's talk about
J, K, and L.
J, K, and L. Those are the ones that you hated. Okay, so let's look at J. The limit of the function as x approaches 4 positively. So,
That means it's coming from the right side.
Yeah.
To the left of 4.
so to help you visualize this, we're just going to cover everything to the left of 4. Great, now drop a car on the road. The road is down here,
Yeah.
and we're going to drive at 4. What y value do we stop at?
4.
Y value.
Oh, 2.
What kind of 2?
Sorry, negative 2.
You with me? And that's the limit. That's
I
all it
think
is.
I was looking at the hole and thinking.
Cars can stop over potholes.
Wait, say that again. Okay.
Okay.
What about K?
So that's
Just a regular 4.
X at 4. Is
Mm-hmm.
that what that means?
Yeah, but here's the thing about limits. You have to have cars. So here's what I'm going to do. Because all of you all tend to get distracted by the other stuff. So I'm going to cover everything but the area around 4. So if we're doing the limit as x approaches 4, we need to drop a car to the left. Where is the road to the left, guys? It's on top. It's this stuff up here,
Yeah.
right? Where's the road to the right?
The bottom.
It's the bottom. It's this one down here. So if I put a car here and a car here and they both drive at x equals 4, are they going to crash?
No,
That's it. That's it.
does not
I don't
exist.
understand that at all.
There's no limit. Limits are about making those cars crash. What about at x is 3? So let's use that as an illustration of the difference between those two types of functions. So if I just cover everything but 3, and I look at the car to the left up here, and a car to the right,
They will
and I
crash.
try to drive at each other, they will crash.
But it
You
won't
guys
be
see
a
that?
continuity.
But it won't be continuous. You can have a limit without a function. That's
So
right.
So they crash at 6.
Yeah, so the limit is 6 as x approaches 3.
But then if we found that, so say we knew like, okay, the limit is 6 as x is approaching 3.
Mm-hmm.
And then you're saying like, is this function continuous for some reason? We would then plug in 6 or plug in 3 into the function.
Always x values. You're always looking for x's to get at y's. So if you get an x of 3 and you try to plug that into the function, will it plug in anywhere?
No.
No. So the function at 3 is d and e, even though the limit at 3 is 6.
Okay.
You guys with me?
Question.
So far, so groovy?
Yeah, I think
What's
so.
your name again?
Wes.
Wes.
Yeah.
Yes.
I'm
Hi,
just
Wes.
going like, I'm working like the other direction. I'm working like the most
You're
recent.
going recent back to the
Yeah, and
old
I
stuff.
I did that, but like, I don't, it's already like,
It's so far
I'm
away,
way
right?
out, yeah.
Yeah.
It's gone.
yeah,
Yeah. So we're gonna bring it back for a
Cool.
hot second, and then we can forget it again until the final.
sweet.
Yeah. It's
In my
I
mind.
know how this really works. I understand. So
So,
what about x approaching 2? Where's the car to the left, guys?
there's no car.
There is a car.
Oh, wait.
You
Yeah.
hop over to the left of 2 and you look for a road. There's your road.
Oh,
Right
yeah.
there.
It stops.
So
And if you hop to
4.
the right of 2 and you look for your road, there it is. And if I drive this car at 2 and this car at 2, are they ever going to crash?
No. That does
So
not
does-
exist.
The limit exists at 2. That's it.
So, question. Like, when you were doing the 4 and then you had that positive sign on top,
Mhm.
what if that was negative? You're looking on the left side. Is that
You would be
correct?
coming at it from the left
So,
side.
if I
exactly.
cover my paper from.
So let's do that. If we were looking at the limit as x approaching
4.
4 negatively, I'm going to cover everything to the right of it.
Okay.
Where's my road to the left?
At 6, right?
It's up here. And if I drive it at 4, I'm going to end up with a limit of, or sorry, if I drive it at 4, I'm going to end up with a limit of 6.
Makes
I didn't
sense.
get that one.
No, sorry, 4, not 6.
So, like,
6
on
is
J,
negative.
do you have the.
Yeah.
Okay, so instead of having that plus sign, it will be a negative
Okay.
sign. And
Do
so
you
you would
under-
cover the left
Should we
side.
do like 4 positive?
Yeah,
Okay.
exactly. 4 positive would be the other
Yeah, right
side.
around. Okay.
That would be approaching 4 from the right-hand side.
Okay.
And we end up with a limit of -2. Remember, limits are just dropping cars on the roads,
Okay.
and to get a road, you need a function. These are all roads. So it really is highly visual. Okay?
Okay.
When we're talking
Okay.
about, I think G where it's, where f of 2, so,
Function at 2.
yeah, so it
So-
doesn't obviously exist.
That's right.
That, like, equation or function would be at some point 0 over 0.
A over 0.
A over a number over 0.
Some number
There would
over
be a
0.
vertical
So
asymptote.
whatever this function is
Okay.
that creates this vertical asymptote, it would have some number over 0 if I plugged in 2.
Just write that
Nice.
way.
Absolutely.
Don't be yaying, this is like hours. I
No.
still wanna cry.
So technically, when you say f to 0 or limit of as it approaches 0, it's technically the same thing, right? Is that what you're asking?
No. So limits are about driving on the cars.
Okay, driving cars.
on the roads
Okay.
with the cars. The function is a vertical walk. So if I'm finding the limit as x approaches 4, that's d and e because one car doesn't crash into the other. But the function at 4 is 2. You see that?
Mm-hmm.
Okay. So that vertical walk, we're looking for anything solid. Where is this beast discontinuous? Just check through the x boxes as we go.
2,
2 and
3,
and
4.
good. So let's prove continuity at another place. So what's the limit as x approaches 5, guys?
The limit as x approaches 5.
Mhm.
-2.
Yeah, so you drop a car to the left, you drop a car to the right, they drive at each other, and you get -2. What's the function at 5?
Function. -2.
Do the vertical walk, -2. Does -2 equal -2?
Yep.
And those are your 3 conditions for continuity. The limit exists, the function exists, and they equal each other. You guys with me? Okay. So we can prove this visually. Groovy?
Yeah.
So
This
far,
is
so good.
easy once you start
Mhm.
adding like
Kind of.
The visual, that's why I always start with the visual. Even though it looks terrifying, it's actually easier than the math. So let's do one with math. Shall we?
Real quick while we're right there on that, can I ask
Yeah.
a quick question? Like what about L, like if the function equals 4?
So do your vertical line test. Just walk
Would
until
it
you hit
just
something
be
solid.
2?
Yep.
Okay, just be 2.
Yeah.
Okay, cool.
Yeah.
Now, if this was all, these were like filled in, those would also be
Careful.
limits.
So let me draw a circle. That's a shitty circle, but we're gonna go with it anyway. Okay. When I do the vertical line test, this is a function at 2 places and 2 places only, right there.
Yeah.
And right here.
Okay.
Because
Okay.
they touch, right?
Well, because there's
Or solid.
there's a single output for one input.
Oh,
The
okay.
definition of a function is you have one unique individual output for every input. But if I plug in this x, I have 2 outputs, don't I?
Mhm.
Okay? So you wouldn't be able, the reason I'm doing this is you wouldn't be able to fill in this hole and still have this here, because you would have 2 outputs for the input of x equals 4.
Okay.
You have to have one and one only. Notice that if I have this, these are both open. If I have this, I can put something elsewhere, or I can fill this in, but I can't have 2 dots here. Same thing here, unique individual output, unique individual output. Okay.
So that means because this is there's
That's the-
nothing
yep.
on that side and nothing
Open
on that
circle, and then a closed circle, which gives you your function. Okay? So let me show you something that looks like this. So if I ask you guys to find vertical asymptotes, horizontal asymptotes, and holes, could you do it? You want something to brace it against? Here?
Yeah.
Oh, this would be better.
Thank you.
I don't want to set your phone on fire. There you
Okay,
go.
I'll continue.
Okay.
Oh, what was the equation? I'm
So
sorry.
for the vertical asymptotes, you would just factor the bottom and then set it to, make it equal 0. So
Good.
it would have 2, wouldn't it have?
Well, yeah, so remember, vertical asymptotes and holes share something in common. They both divide by 0. So once you get the denominator to 0 and you find all the x values that give you that, check them with the top to see if it's a vertical asymptote or a hole. Let me demonstrate.
Okay.
So we're checking for VAs and holes. My upside down writing is awful. It's like a little kid. Vertical asymptotes and holes.
Okay.
So what multiplies to 7 and adds to 8, guys?
8 or 7?
What multiplies
Oh,
to 7 and
okay.
adds to 8?
X plus 1 and X plus 7.
Yep. So I'm going to keep these real simple for you guys, because I'm testing you on the mechanics
Think.
and not algebra, okay? So equals 0, right?
Mm-hmm.
So I get x equals negative 7 and x equals negative 1. You guys with me so far?
Yes.
Do I, yeah.
That is both where there's vertical asymptotes or holes?
Yeah, it could be either or, right?
Okay.
So we don't know for sure which one is which.
Oh.
We just know that these are either vertical asymptotes or holes because they make the denominator go to 0. So now to check to see which one's which, we plug them into the numerator. So this gives us an answer of what over what when we plug in negative 7.
0 over 0.
So this is a hole. You guys with me?
Mm-hmm.
And when we plug in x equals negative 1 to the top, what do we get?
6.
6.
Yeah, 6 over 0, which is a what?
A vertical asymptote.
That's a vertical asymptote. Any number over 0. Right?
Okay.
And then and then -7 is a whole,
That's a whole.
because it would be 0
Mhm.
over 0.
So you're saying technically, like, a first step to tackling this guy is to factor the bottom,
Mhm.
set the bottom to 0,
Mhm.
and then even though they both equal 0 at the bottom, plug in what you got from there to the top to find out if you get a 0 or a number.
Exactly.
And that's it.
Exactly, because
Okay.
it tells you which one's which.
Okay.
Now the last thing we have to test is the horizontal asymptote. You guys remember how to do that?
If
No.
it's 0, 0, right?
That's the limits as x approaches infinity.
If
Because-
it's 0 over some number.
X approaching infinity.
Oh, we gotta turn it into 0.
That's highest power survives. So what's your highest power on this sucker?
X squared.
Good. So you have a 1 next to it, right?
Mm-hmm.
So you're gonna get some 0 over 1 because nothing survives on top and only one term survives on the bottom.
Okay.
Wes?
Wait,
So far, so
say
good.
that one more time.
I said, so when we do horizontal asymptotes, we check it by doing the limits as x approaches infinity. And I'll show you on the beast in a second why those are connected. Okay? So all you need to know for this is the highest power is the one that controls your end behavior. So your highest power survives, everything else dies. So your highest power is x squared. You have a 1 sitting here next to this x squared. So this is the term that's going to survive.
The 1.
So there's nothing on top that survives. So you literally have 0 plus 0 over 1 plus 0 plus 0. So you get 0 over 1, which equals what, guys?
Does not exist. Or 1. Or 0. My bad. Too much math.
So now you have a horizontal asymptote at y equals 0.
Is it always like
0
that?
over 1.
Yeah,
Always?
it's always like, well, what do you mean like that? Is
What
this
if
the
we have-
procedure?
What if we have 2x squared plus 8x plus 7?
2x squared plus 8x plus 7?
Yeah.
Well, that would change all of this, but that aside, you would get 0 over 2.
Oh, okay.
Okay? But if you had x squared plus 7 over x squared plus 8x plus 7, you would get a 1 over 1 surviving. So
Oh, I
you would
see.
have a y value of 1 with the horizontal asymptote. So let me show you guys how this is related to the picture. Horizontal asymptotes are literally the limit at infinity. If I drive off the page to the right, is my y value limited to anything as x grows?
No.
Yeah.
I mean, yeah.
Negative
It's
-2.
limited to -2. It's
Oh.
literally going to be locked into that horizontal asymptote. The limit as x approaches infinity is your horizontal asymptote. Okay? What's the limit as x approaches negative infinity?
Positive 2.
Positive 2. Very good, Wes. How do you guys feel about that?
So can we do one that the horizontal asymptote would be greater than 1? Like how would
Absolutely.
So with our one that we just did, horizontal asymptote would be at 0.
So you either have the function growing to 0 and staying there forever, or
Yeah.
shrinking to 0 and staying there forever.
Okay, yeah.
Okay, and you can graph it to figure that out. You could graph this original function to see its end behavior.
Oh, I
You
think
can always graph it. When in doubt, graph it out, especially if you're checking for horizontal asymptotes and you're not sure of it. Graph yourself. Yeah.
So for the horizontal asymptote, you just literally just do the highest power thing. So
Mhm.
obviously, if there's a number on the top,
Mhm.
So as long as you get a number, that's where the horizontal asymptote, and it's not 0 over 0, or like
Wait, say that again?
maybe it's good. I'm sorry. I was more thinking, like, how would we prove that there isn't a horizontal asymptote?
If you do this answer and you don't get anything as your answer. So if you get something over 0,
Yeah.
that's D and E, because you can't divide by 0. So if you have a highest power on top but none on the bottom, you'll get something over 0, which is D and E. And that means the function's either growing like this out of control or shrinking like this out of control. It's not converging to a y value and staying there.
something over 0, you know
Exactly. So there's literally no limit to the function as y gets really, or as x gets really big. Y is either going to get really big in the negative direction or really big in the positive direction. It's not limited.
Where like if there's a highest power at the top and the bottom, then you know you're most likely okay. Yeah.
So, what's the limit as x approaches infinity on this guy?
What's the equation?
2.
Foot 5.
You like this?
Me too, especially for autistic kids, because they don't like touching, but they really enjoy the foot 5 thing for some reason. Yeah. I don't know how I know that, because I don't have kids and I don't teach children, but but they really enjoy that. I don't know what that is. They're all about the foot 5.
Okay, now how do you get that just by looking at it? Is it because
Yeah.
it's the 2x squared?
That's your
over-
highest power.
And you have a
So
1 on the
you have
bottom,
two
like a
here
1
and
hex
a one
squared, so
here.
it's 2 over 1.
Yep.
Okay.
So if you do the limit as x approaches infinity, if you go through the math, which I taught you guys how to do, but I said you never had to do it on a test, this is good enough. You end up with a 2 and a 1 surviving.
Mm-hmm.
So you have a horizontal asymptote at y equals 2.
Because of that 2 on the top.
Because of the constant coefficient. So there's that hidden,
It was 3x squared or 2 over 3.
or that hidden 1. Yeah, if this was a 3x squared down there, it would be 2/3. Exactly. And the reason is, the highest power defines your behavior. Think about it. X squared, that's a parabola, right?
Mm-hmm.
That defines your end behavior,
Okay.
right?
Yeah.
X cubed looks like this.
That's like the
That
first
defines
time I
your end
haven't had to
behavior.
do like 2x squared over x squared plus 4 over x squared over x squared over x squared minus 9 over x squared.
Minus 9 over x squared. Lots of x squareds. So what about what about vertical asymptotes and holes? Are there any on this?
Yeah.
Okay. So VAs and holes. Oh my god, upside down writing. Ugh.
X squared minus 9. So
Go with your gut there, Wes.
Good
What were
idea.
you thinking?
I mean, there's one at 3. There's either hole or vertical asymptote at 3.
And
So
Negative
-3,
three?
yeah.
good. So check them on top. So if you plug in 3 to the top, what do you get? Some number, right? Doesn't go to 0.
It's gonna be the same.
9 18 is 22. 22 over 0. And 22 over 0.
Mm-hmm.
This is a vertical asymptote. And this is a vertical asymptote. So it can have 2 vertical asymptotes.
Okay.
You guys see how these work?
Mm-hmm.
And if you graph this, you'll see it.
well, they're both 22 over 0.
Yep, because if you square this -3, you get 9. Times 2 is 18, plus 4 is 22.
So like in parentheses it'd be 3 squared close parentheses
Mhm.
and then 2 on the outside.
Mhm. And then 2
Okay.
open parentheses, -3 close parentheses squared.
Right.
Would still end up with the same number. So just for shits and giggles, you guys, go ahead and graph this one. It's a great skill to have when you're in the middle of the test and you're like, I think I have 2 vertical asymptotes. It's an easy enough thing to graph it and check it, right?
Mm-hmm.
Very easy.
So so this I obviously didn't put in right, but that's how I would have put in the -3.
Aha, careful. You're putting in -3 squared as your input.
Right.
But what's your input? Just -3. That's your input.
So it should really be like 2 -3.
Exactly. Hit enter and you'll see.
I do know there's a way to get positive and negatives. I just like for some reason still can't figure out how to put it in my damn calculator.
Because what's being squared?
The -3.
Exactly. So what's -3 times -3? 9. Yeah.
Like to me it makes
Sometimes it's easier to do it in your head than it is in the calculator. Especially with these small numbers. And you guys know your 9 times tables and your 8 times tables. You know, we learned that stuff. So sometimes it's easier to use your brain than it is the calculator. Okay?
we know that's not a hole because we know those are vertical vertical asymptotes versus wholes?
Because of the numerator. It's a non-zero numerator. O for whole, A for asymptote.
I wrote this wrong then. So a whole is a 0 over 0, and a vertical asymptote is a number over 0.
Literally an A over 0.
Okay.
A for asymptote. O for whole. O. O for whole. Now, how do you guys feel about those? So now you can check for continuity. Is this thing continuous for all x?
No.
God, no. Where is it discontinuous? That's right, 3 and -3. Don't overthink them, guys. What else?
Is that 9.1 and 9.2 in
Pretty
a
much.
nutshell?
Yeah, in a
Wow.
nutshell.
Oh. I said 3 and -3, I just don't know why.
Okay, I guess 9.3 says, no one be able to describe what the following is in your own words.
Mhm.
So as the limit of age approaches 0, and then you have. Do we have to like do those math?
No, I said be able to describe
Oh,
it.
just describe it. Okay.
So what is this? What is this, guys?
What is that?
Wes, do you have any ideas?
No.
That is, is that the derivative?
Yes, it is.
What's the long way, right?
Yeah, it's the fundamental definition of the derivative. It's a slope between 2 points when you squish the distance between the 2 points together. And you convert this from an average rate of change to an instantaneous rate of
Would
change.
you accept derivative
IROC
as
and
a,
A-rock
Yeah.
and I-rock?
Yeah, this is the
Okay.
A-rock. When you incorporate this part, it becomes the I-rock. Yeah, that's it. It's the derivative.
So we could just say that in the exam, derivative. And then you'd be like, how did they get it?
Well, I mean, like fill that out a little bit,
Oh,
flesh
okay.
it out a little bit, but yeah, that's what it is. In your own words.
Derivative.
Tell me what's happening with this. You're taking the slope between 2 points and you're squishing the 2 points together to create a single point. That's all. That's really all it is. Does that make sense? Mammal's like, yeah.
Taking a slope of 2 points and squishing it.
together?
And squishing them, and you guys
To
are
make
like,
one point.
that's gonna be my words.
We'll do a different synonym for like
I'm gonna draw
squishing.
But-
Dory from Finding Nemo.
Yes, Dory.
Squishing them together.
Yeah.
Two,
Just take a look at the front page of 9.3, the handout, and you guys will see exactly what I'm talking about.
See that bad boy.
I know there's so many handouts, I'm sorry.
It's cool.
That's it.
9.6.
Slope is just the average rate of change between 2 points.
That's the slope part. This is the f of x plus h minus f of x over h. That's the slope, the average rate of change between 2 points. And now when I squish those 2 points together, I create an instantaneous rate of change.
Instantaneous rate of change. I-rock.
Do you see it?
Yes, ma'am.
Awesome. She's like, all of that right there. Page 1 of 9.3.
How to highlight
So
that bad
that's
boy.
taking 2 points, putting them together,
Squishing
and
them
then squishing them together.
To
and-
make 1 point.
to make 1 point.
To make 1 point, or, okay.
Yeah.
Which is the IROC.
Yeah, it's the fundamental definition of the derivative. It's the long way on the derivative.
Together to get a point.
Yeah.
Get a point,
Perfect.
which is IROC.
What else, guys? We're scooting right along. 9.4 is the shortcut. You guys can do that in your sleep now.
Wait, what do you mean by be able to find A-rock? Is that the same thing?
It's the average rate of change. It's this part.
Just that part.
Mm-hmm. Slope. It's y2 minus y1 over x2 minus x1.
I slope.
Yeah, you can do that. What else? 9.4 is easy. 9.4 is simple.
Well, I don't know about that.
Make it pretty.
Yeah, I got tax class. Can we do 9.9 on Thursday?
Absolutely. Yeah, we're gonna spend a lot of time on the homework from
Okay.
9.9 because what did I give you guys? Like 4 problems, 5
Yeah,
problems?
that wasn't much.
Yeah, there wasn't much, but they're rough because
Yeah.
they're all applications. There's no getting away from them.
Yep.
Yep,
Okay.
definitely, Wes. Thanks for
Question,
stopping by.
so-
You bet, thank you.
There's
I
a
appreciate
jar of chocolate there if you want
it.
anything.
I'm fine, thank you,
Seriously.
though.
So Mondays and Wednesdays, or Monday or
Take care.
Wednesday
you too.
tomorrow, are you going to just like review for us?
Uh-huh.
Or are you just
Just
gonna
like
jump
this.
into the what we did today for the Tuesday class?
No, we're gonna do review.
Oh, just review? Oh,
Yeah,
okay.
that's it.
Wait,
Review
what?
is it.
Our class is just gonna do review.
Mhm.
We're not gonna do what this class did today.
So you mean I
Yeah, that's why I
left
told you
in?
don't go to, that's why I.
Okay, we're just gonna do review. I'm just gonna smash all of 10.1, 10.2, and 10.3 into one class for you guys.
That's why we want to start going,
Yeah,
go to their classes.
yeah,
Okay.
yeah. It's okay, we're just gonna do review. You guys need it. You need the time, clearly, right?
Oh my gosh.
Well, you don't, cause you're in the early morning, the Tuesday, Thursday class.
Yeah.
So you didn't lose out, but this one does and this one does. Yeah. Yeah. So you guys are already ahead of the game. But after the test, we'll all be on the same page, hopefully.
This is
Could
gonna help me.
you, do you guys wanna keep moving to the next section?
Yeah, 9.4.
Okay, I'm fine with that too.
Okay.
Can we just like hit like
I just
different
had no
type
idea
of like
what the
examples?
problems for homework.
For homework, or for 9.4?
Like
Yeah.
I worked with a math professor downstairs, and I was like, yeah, like he's like, do you want to come into my office and continue this? Because someone needed there. I'm like, yeah, I think I'm gonna tap out. Like
When
before I
was
just start
this?
crying this morning.
This morning? Oh, was it down in the math lab?
It's where there was no tutors available. Like usually
No.
Justin's there, but he didn't show up, and so then I asked like a couple of the math professors. I'm like, well, I didn't know if they were, but they were in that area, so. And
They
so
are.
I worked with Dawn,
Everyone on the first floor is.
and he's
Oh, Dawn.
he was nice enough
Such
to
a
like
sweet
say
old
that he
cookie.
helped me, but he's just like, go to the, and I'm like, so is this D in or is this D out? He's like,
You're
so
like
we
this.
worked for like 20 minutes on this one problem, and I didn't get anywhere, and I'm like, and then
He
people
did
came
the
into
chain
the room.
rule on you, didn't he?
Well, I
He
think
said,
he
let
was
you
just-
equal blah, blah, blah.
I think
and-
he was just looking at me like, this chick's crazy.
Ah, you're not crazy. I just have a weird way of doing things.
Like, get me to some like tutor.
He's all like,
he
he's
said
all like,
some-
I'm just gonna bullshit and see if she has it right.
Yeah, it was kind of like one of those.
Okay,
things where-
9.4.
Find the equation of the line tangent to y equals 6x squared minus 10x at x equals 3. Why not?
We just find derivatives on these guys, right?
Mm-hmm.
So we're basically trying to get to y equals mx plus b.
Mm-hmm. That's right. Oh, yes. Oops, shit. Equation of line is y equals mx plus b.
Y equals.
So RTFQ, guys.
Oh, what does that mean? Read them.
Read the fucking question. One must not simply jump into solving the problem. One must read the fucking question.
I can see that meme.
You can see it, yes.
Oh god.
You're gonna be a math nerd by the end of this, Brenda.
I already
so great.
been a-
It's so
If we
great.
plug 3 into the derivative, we get the slope.
Good. That gives you m. Where do you go to get y?
Then you plug whatever.
Derivative. Oh, sorry, the regular original function.
Whatever
Okay.
you get as that
Is your
number
y.
goes into the original function.
So y of 3, just for giggles, is gonna be 6 times 3
Wait, I'm
quantity
gonna
squared.
Get this question right over
Jesus
here.
Christ. Minus 10.
Because x into your
Times 3.
function gives
Wait,
you
can
your
I,
y, and x into your derivative gives you
Bring
your
that bad
slope.
boy over here. Thank you. I got it.
Say that again.
Are you recording now?
Yeah.
Really?
Yeah. Do you want it? I'll airdrop it
course
to
I
you
want
and put it
Yeah,
on your
drop it
YouTube
to you.
channel. He has a YouTube channel.
Just for this.
Well, I have a YouTube
Flippin'
account.
awesome.
It's not
That's
a channel.
awesome. Well, he's got a channel now
Yeah.
because he's putting up content.
Okay.
So what's
You can
my
put it under Metro.
what's my derivative, guys?
18x minus 10.
Careful.
No.
12x.
Oh, 12 actually.
Nick, are you good with that?
Yeah, 2
Yeah.
times 6.
You finally caught the
Yeah.
caught the derivatives now. You're up to speed with them. Awesome,
Since
because you
2
and I
weeks.
drilled this. We drilled this last time. Do you remember?
Yeah.
Okay. So now, what do I plug into this to get out my slope?
The 3 that you add. So 36 minus 10 is 26.
12 times 3 is 36 minus 10 is 26.
26.
Okay, so what am I missing now?
Your B.
Good. So what do I write down here?
So 26 equals.
Careful.
No, that's your Y, right? Or that's your slope. I'm so sorry. My 24 equals 26
M times
3
good
plus B.
plus B.
So 26 times 3
78.
minus 24 is 54.
Yeah.
So B equals 54. Wow, why am I so good at this now? But then when it comes to the exam, I'm gonna have so much anxiety.
So let me just tell you guys, math anxiety is not abnormal. And what I want you to do is I want you to look at me. Hi.
I know I am late. I decided to go to my other class. I was
Yeah, no
wondering,
problem.
are you gonna be here tomorrow?
Yeah.
Okay, what are your office hours? Perfect.
But
I've got
Wait,
9
can I see
a.m.
the
office
clipboard?
hours. Yeah. I've got 9 a.m. office hours, and then I have afternoon office hours. So
Perfect. I'm gonna
tomorrow's
just take
what?
a quick picture of
Tomorrow's
this, if
Wednesday,
that's okay.
right? Yeah. Tomorrow's Wednesday. So, how you doing, chick?
I'm doing okay. I went to the doctor this morning. They didn't know what was wrong either. They just said that it was pretty probable that what they said at the hospital was true. And,
Unbelievable.
Yeah.
And you never want to see any of these people again.
No. Never again.
Oh,
Yeah. Yeah.
Right.
Welcome back to the full. I would hug you, but I'm like
Either
ensconced.
way.
So,
But
yeah, let's set up a time where we can get you caught up.
Okay.
Or
Well, you
I'm
already
gonna
know
kick
what
these guys out in
exercises
10
to do.
minutes. I don't know if you want to like hang.
I can totally hang,
You
but
wanna
I mean,
hang?
I figured you had stuff going on after. I didn't want to. Okay.
I've got students until 3:30 or 4.
Right, didn't
So
we-
So then
Okay, I
what-
can
what
definitely
is
later.
this
I'm gonna
value?
use the restroom really quick.
yeah, go do
but-
that. If you
Didn't
go
you-
this way and then turn left and cross the hallway, there's private restrooms.
Perfect. Can I leave my backpack?
God, yes.
Thank you.
That was
24. So when we plugged 3 into the original function, we
Yeah.
got out the y value.
3 into the
Yeah.
into your original.
So remember,
just
you
your
guys,
X, you plug in an X to an F of X
you get out
and
of
Y.
good.
Hey, remember
And
what
you
she always
plug in
writes,
an
like
X
x into the
to a
function gives you
derivative.
y,
You get a
Slope.
slope.
and then x into the derivative.
I'm living
gives
off
you
that now.
Girl, I'm so proud of you guys. Like, there's a lot in this stuff. There's a lot to know. But you guys are doing really, really well. And in the test,
B equals
Yeah, in the test.
you're anxious, right?
Yeah,
Are
I
you
guess
anxious?
so.
Are you anxious?
Oh yeah.
Are you anxious?
A little, yeah.
Thank
Look
God
at
for
me.
pod at night.
Seriously, right?
Seriously, right?
Seriously. So,
It's the only reason I can sleep. In like 2 hours.
Dude, I would be like
Me too,
sleeping
chick.
in
Me
if I did that.
Serious. No one ever would
I still
expect
get
me
my
to
ass
smoke
up
all
at
night.
early in the morning. But anyway, so
I can't only imagine.
I,
I'm
I,
sorry.
I want you guys to look at me
Revelations
during the.
right
Aw.
Probably for me too, huh, Mama? Sorry.
Suck it up, guys.
As I'm like, no, I'm going to
We-
church and like.
We have lives outside of this place. We all are, we do things.
I might
So
just go buy a blunt.
just look at me
Okay, I will
during
look
the
at you.
test. Just look at me during the test, and I'll be like, "You're cool. It's good. I got you."
Okay,
If you're stuck on something, what are you gonna do? Sit there and want to die?
pretty much, but
No.
I'll go ask you.
Yes, you will. Yes, you
What
will.
was the B?
Do you
Negative
54?
54?
54. How would you get negative?
I
I
don't
don't
know.
know.
26 times 3.
Okay.
That's 78.
Oh, it will be negative 54, won't it?
Did I get a point?
Ooh, shouldn't you?
Yeah.
Wait, why would it be negative 54?
Because if you're subtracting
Yeah.
78, it'll be negative 78 plus 24 gives you negative 54. So your answer will be, yeah,
Negative 54.
negative.
That's my number.
So I want you guys to, if you get stuck in the test, come up and ask me for help. I'll give you a nudge. I'm not going to leave you hanging. Come talk to me. I got your back. But you got to come talk to me.
I will
What's
use
Is
you.
that a giraffe?
Use
Yeah.
me.
Not in
I
Spain.
love your giraffe socks.
My socks were really dirty the day I got to Spain, and then so I bought $30 ones. My
Yeah,
stroll
because
size.
it's what you do.
Makes economic sense.
Yeah, we got stuck in an airport overnight. What was it? Heathrow, I think. We were stuck in Heathrow overnight. It was awful. And I was like, I need underwear because I didn't bring a change of clothes with me. And I spent like $30 on shitty, like, tighty-whitey grandma underwear. In
That's called
You always hear stuff you never
inelastic.
inelastic,
Right.
yes. Yeah, it is inelastic.
So-
And so were the tidy whities, inelastic. They didn't stretch much. And they didn't fit well.
Ow.
Ow,
So-
sucked. Yeah, it cut
This
my legs
is
right here.
9.4.
I feel
Yeah.
good. Yeah.
Yeah.
Basically,
That's 9.4 in a nutshell? That's it?
is like we're finding
Well,
the
That's one thing
Functions.
you can do with derivatives. But what else can you do with derivatives?
A lot.
And
I don't know,
and then
take
we,
them?
And then you know how we write, like at the end we have to
Kidnap
put
them?
y equals
Mm-hmm.
the number we got for slope, x,
Yeah.
plus, and then the number we got for b, right?
Yeah.
That's how we have to write it, right?
Mm-hmm.
that would be the function of
Yeah.
whatever function of the equation. Function of the line.
What are your office hours, bro? You don't have office hours, do you?
Yes, I do.
It's from 9 to 9:45 tomorrow, I believe, and from 1 to 1:50 tomorrow.
Oh, okay,
Or
okay.
1:45.
And Thursday you say you won't have any.
Yeah.
Alright, I'm gonna jump off a bridge now.
I need a 9 there.
Well, maybe I can make it tomorrow.
Oh, that's just cold. Okay, hang on.
How?
Y equals x
Yeah.
cubed
one of these.
plus
Black
Oh, you stop.
9x squared.
I need the sugar, okay? It's either that or.
Plus 8.
Is the shortcut of to find derivatives, is that just the
What's the derivative of that?
3x squared plus 18x?
Great, that's the shortcut. You just did it.
Because the other one was like the y.
The shortcut,
To the limit?
yeah, the
like,
shortcut
over, you know, that whole thing.
circumvents this procedure. Oh, where the fuck is that? I don't know. It's on the back side of this, I think. Yeah, circumvents this procedure right here.
This looks a lot like what is it called? Like without the limit thing.
The average rate of change, AROC.
No, yeah, but it looked like something we used to do in finite.
Yeah, it's exactly what you were doing in finite. It's the slope
Yeah.
between 2 points. And they were prepping you
But
for this
wasn't-
moment.
Wasn't there like
That's what they were doing.
like the formula? What was
Yeah,
it called? What was it called?
It's the slope of the tangent line.
That's
not what they
called it.
Yes, that's what they did. Slope of the tangent line. They did.
Okay, whatever.
It's in this book. It's the slope of the or the average rate of change between 2 points. The slope of the tangent line, or the slope of the secant line. The secant line.
Nope.
Yeah. No. Whatever. It is the secant line. Okay. So I want you guys to find the point where the slope is 0, or points.
Wait, I'm gonna say y equals f plus
Okay.
9x.
When we do the review tomorrow, can we say like what section we're doing? Like this is 9.1.
Sure, but on the test it won't be like that.
That's true.
So if I throw something on the board, you got to be able to tell me
That's true.
where it's from. Right?
Yeah.
Okay.
Slope
So-
is 0.
So how do I do that? What's the procedure for this?
Derivative.
But you could, yeah, derivative. Derivative's like the first thing for everything,
Almost.
Yeah.
Except when it's not.
except when it's not.
That's why you must RTFQ.
It's 3x squared plus 18.
18 what?
X.
Mm-hmm. Okay. Now what do I do?
You have to
Plug
set
in.
each of those to 0. No, wait.
Well, sort of.
Fine.
Slope is 0, so what do I set equal to 0? X or y prime? Y prime.
Y prime, yeah. Well, that's
So
what I
y
meant.
prime
Each of
equals
these,
0.
I'm sorry.
Yeah,
I meant
3x
each of the
squared
derivative.
plus 18x, but not these terms. You have to factor this.
Yeah, I was just
Right,
gonna
right, right.
say
Will
because
be 3x and then x plus.
because there's 2 x's.
Here's why. If I set this equal to 0, does that make this whole thing go to 0? No,
Wait, what?
not necessarily.
Oh,
If-
because it.
Because you can add, but if you multiply by 0, everything goes to 0. So if I yank 3x out of this, I'll be left with x plus 6. Is that right? So if 3x goes to 0, this becomes true.
So it's negative 6.
If x plus 6 goes to 0, this becomes true. So what makes 3x equal 0?
0.
0.
Okay, so that's one of them. And what makes x plus 6 equal 0?
Negative 6.
X equals negative 6. Okay, do you see why the
Factor
difference between
first.
here and here?
Yeah, with
You
that.
never would have gotten to the negative 6
No.
up here. So always factor them, because when you multiply terms by 0, they go to 0. So if this is 0, this is true. If this is 0, this is true. So that's why we said those equal to 0. Okay? So did you do everything you wanted?
No.
What are you missing?
Now you gotta plug in. Don't you have to plug in those numbers
Where?
to the original?
To
Find
get what?
your y.
Good. So what's y of 0?
0. Or 8. I'm sorry.
Good, equals 8. So we have a point 0, comma 8. And that's one of the points.
Wait. You said 0, comma 8, right?
Mhm.
Okay.
Yeah, that's your x, comma y. That's the point on this function that has a slope of 0.
Okay, negative 6, and then we're trying to find our y. I don't know that.
Yeah, y of negative 6.
Negative 6 times negative 6 is positive 36 times negative 6. That I don't know.
Negative 196.
196.
Negative 198.
198.
Yeah. Negative 198.
This is such a big number.
So I don't know, do it in your calculator. Calculator. Or let Nick do it for you. Come on in, Chip. Take a rest. I'm going to kick these guys out in about 2 seconds.
So we said negative 6
Actually,
cubed
it's really fun.
plus 9 times.
Is it calculator?
That's the math teacher. It is really fun.
In my calculator.
116.
Just like that.
Really?
Mhm.
Okay.
116.
116
Like the
for
big
this answer.
numbers that I have such a hard time with.
Okay, so that's a y.
So the number is negative 6.
You were definitely more
comma
valuable than Mike.
116.
Squishy grapes.
Thanks, Brenda. So what do you guys think? So if you were to
No.
graph this function up here, you would get those 2 points as your maxima and minima. Now, which one do you think is your max and which one do you think is your min?
Is that what we did today?
Kinda, yeah, but we did it with the second derivative instead.
Oh, yeah.
So much fun. You guys will get, well, you were there, but Autumn, you'll get it after the exam.
Yeah.
I'm gonna make you guys wait.
I'm not really worried about that amount of stress on.
So which is the max and which one's the min, you guys?
Yeah, I'm just gonna guess. The bottom one is maxima.
Hell yeah. And the top one's the minimum, right? Let me show you why. This is an x cubed, you guys. This is what x cubed looks like. So here's your 0, or your negative 6, comma 116, and here's your 0, comma 8. This is an x cubed.
Negative 6, 116 is the max.
Negative 6, comma 116, which has a y value higher than 0, comma 8. So it looks like your x-axis is like that. So that's what this would look like if you were to graph it.
So we take any, for the next step to find our slope, you would just take either the negative 6 or the 0.
Mm-hmm. Yeah, but you would get a slope of 0, wouldn't you?
Yeah, with the 0.
Or the negative 6. They both give you slopes of 0.
It's just, really?
Yeah, really. Try it. That sense of curiosity you have, Brenda, that's fantastic, because that's gonna allow you to really cement this stuff in your brain. Experimenting with your calculator and graphing and the functions. You see it?
Yeah.
I literally
Nah.
finally put the right numbers in my
Yes.
calculator.
Exciting.
Okay.
Very.
Okay, so we're gonna continue this tomorrow in class.
No.
And for you two on Wednesday. No, Thursday. Thursday, yeah.
Oh, okay.
Yeah, so you gotta jump on your review. Congratulations. And you two, I will see you tomorrow.